All right, now we'll look at some example problems involving friction. So remember, we are still doing Newton's second law. The acceleration equals the net force divided by the mass, or the sum of the external forces equals the mass times the acceleration. So we're just adding an additional force, which is the frictional force. So let's review quickly a couple of the concepts from the last video. So if I apply a horizontal force to a desk sitting on the floor and the desk doesn't move, that means there's an opposing force acting against me. This is the friction between the desk and the floor. So when the object is not moving, we call this static friction. Now, if I push hard enough for the desk to slide across the floor, then the desk and the floor are moving against each other. We call this opposing force the kinetic friction. So in general, the magnitude of the static friction is less than the maximum value that it can be. It's only going to be equal to the applied force that it opposes. So we write the static friction, F sub s, is less than or equal to mu sub s times the normal force, where mu sub s is the coefficient of static friction. So if a block is sliding across the table, when the opposing frictional force is called kinetic friction. The magnitude of the kinetic friction is approximately constant, so we write it as F sub k equals mu sub k times the normal force, where mu sub k is the coefficient of kinetic friction. The values of the frictional coefficients depend on the nature of the surfaces in contact with each other, and these are found experimentally. And so in general, the static friction coefficient is greater than the kinetic friction coefficient. And again, these are just numbers. These are not forces. They are just numbers that are determined experimentally. So we see in both cases, the friction depends on the nature of the surfaces that are in contact with each other and how hard they are pressed together. That's where the normal force comes in. Also notice that they do not depend on the area of contact. They only depend on the coefficient of friction and how hard they're pressed together. They do not depend on the area of contact. All right, let's look at an example. When moving a 35 kilogram desk across the floor, a woman finds that a horizontal force of 275 newtons is necessary to set the desk in motion, and a horizontal force of 195 newtons will keep the desk moving at a constant speed. What are the coefficients of static friction for part A and B kinetic friction? All right, so how are we going to do this? Well, we'll draw a free body diagram for the desk, put in the forces, and apply Newton's second law, just like we did before. All right, so here's my free body diagram. The block there represents the desk. So we have the weight down, that's mg, and the floor pushing up, so that's the force normal, F sub n, pushing up. Those two forces are going to be equal and opposite to each other, so the desk does not fall through the floor. Then we're going to have our applied force, that's the capital F, pushing to the right, and then we have a frictional force pushing to the left in the opposite direction. Now, so part A, the desk is not moving, so we have static friction. Now, we want to find the coefficient of static friction, and we're given that it takes a force of 275 newtons just to set the desk in motion. So the 275 newtons is the maximum value of the static friction. So notice in the x direction we have capital F, our applied force, to the right minus the static friction maximum force to the left. So I write it F sub s maximum. And those are going to be equal to 0. And then in the vertical direction, we have the normal force up minus the weight mg down, and that equals to 0 since we have no motion in that direction. So we're going to push until we're just at the point where it's going to break free and start to slide. So we're at the maximum static friction. Okay, so those are our two equations
from Newton's second law. And now using these, we can find the coefficient of friction. So that'll be in the next slide now. All right, now from our x direction equation, we had our applied force was going to be equal to the maximum static friction. We also know that the maximum static friction we can write as mu sub s times the normal force. So mu sub s times the normal force will equal our applied force of 275 newtons. We also note that the normal force is going to be equal to the weight mg. All right, since the sum of the forces in y have to be 0, so the normal force up equals the weight down. So our applied force F is going to be equal to the maximum static friction force, which is mu sub s times force normal. So that's mu sub s times mg. And so from that now we have mu sub s mg equals 275 newtons. Now we can solve for mu sub s. And we get the 275 newtons divided by mg, which is 35 kilograms times 9.8 meters per second squared for g, and we get 0.802. So that's our static friction coefficient. All right, now we do the same thing to find part B. We want to find the coefficient of kinetic friction. We're given that the horizontal force of 195 newtons will keep the desk moving at a constant speed. So again, if we're moving at a constant speed, there's no acceleration. So our applied force to the right minus the kinetic friction to the left will equal 0. And again, we have the normal force up minus the weight down equals 0. So we follow the similar procedure as we did for part A to get the coefficient of kinetic friction. So we have the kinetic friction, F sub k, equals mu sub k times force normal, and that's going to be equal to our applied force. So our applied force equals mu sub k force normal, which is equal to mu sub k mg. So we can see in the vertical direction, again, our force normal equals the weight mg. So we solve for mu sub k, and we get F over mg. So our F is now 195 newtons, and we have the mg in the denominator, and we get mu sub k equals 0.569. And again, notice that there are no units with the coefficients of friction. They are just numbers. All right, here we have a 30 kilogram box with a rope connected to it, and it's being pulled along the floor with a force of 25 newtons on the rope. The rope makes an angle of 30 degrees with the horizontal. The coefficient of kinetic friction between the box and the floor is 0.030. What will be the acceleration of the box? So we're going to apply Newton's second law. We know the sum of the forces equals ma. So, and of course, force is a vector and our acceleration is a vector. So we know in the y direction, we're not going to move in the y direction. So the sum of the forces in y equals 0. We'll have an acceleration in the x direction, so the sum of the forces in x will equal to m a sub x. And that's what we want to find, is a sub x. All right, so I've put in the forces. We have a normal force up, the weight down. We're pulling with the force F at an angle of 30 degrees with respect to the horizontal. And then our frictional force, of course, is going to oppose our motion, so that one is going to be horizontal to the left, since we're pulling to the right. So the applied force on the rope we have to break into horizontal and vertical components. So the horizontal component in the x direction is going to be F times cosine of 30, since it's adjacent to the angle. And then the vertical component will be F sine of 30. So now we just apply the sum of the forces in y equals 0 and the sum of the forces in x equals ma. So first of all, let's do the y direction. So sum of the forces in y equals 0. So we have F sine theta, or F sine 30 degrees upward, plus force normal upward, minus the weight mg down equals 0. Now we're going to need the normal force to put in for our kinetic friction. So we have F normal then equals mg minus F sine of 30. Now we can plug in the numbers. And so M, of course, is 30 kilograms, G 9.8, minus F sine of 30, so F was 25 newtons, and sine of 30 degrees. And then when I crunch those numbers, we get 281.5 newtons. All right, now we only want to have 3 significant digits here, or 2 significant digits. So rather, we'll wait till the end before we do any rounding. So now we apply the sum of the forces in X equals MA. So we have F cosine 30 to the right minus the friction F sub k to the left. That's going to equal to MA. We'll solve for A. So we get F cosine 30 minus F sub k over M. Then F cosine 30 minus mu sub k F sub n, substituting in the expression for kinetic friction. Now we've got numbers for everything, so we can plug in the numbers. So our F is 25 newtons, cosine of 30, minus mu, which is 0.03, times the normal force, which we already found to be 281.5 newtons, divided by the mass 30, and we get 0.44 meters per second squared for the acceleration. Okay, so now we're done. But again, see, we're just applying Newton's second law, just like we did before.
One other thing I wanted to point out in this particular example is that notice that the normal force was not equal to the weight. So when you have a box sitting on the floor, sometimes the normal force is equal to the weight, but in this case it's not. And the reason it's not is because we have a rope attached to the box and we are pulling not only horizontal but also pointing upward a little bit. So since we're also pulling upward, the normal force is going to be less than the weight. So be careful of that when you are working your own homework problems. Make sure that you put in all the forces and break them up until they're into their horizontal and vertical components. Don't just assume that the normal force is equal to the weight. But again, we are just applying Newton's second law. We're drawing free body diagram, put in all the forces, and then apply the sum of the forces equals MA. All right, that's the end of this video. And in the next video, we'll do some more examples with friction. Hi, Dr. C here. I want to ask you to please help support this channel. There are a number of links in the video description to Amazon.com. If you purchase any items from Amazon by entering through these links, even if it's not one of the items listed, I will receive a small commission that helps to produce more content. There is no additional cost to you whatsoever. Also, please leave your comments, questions, or suggestions below. I want to thank you for support of this channel and please subscribe. I hope you find my videos useful.